Okay, so welcome everyone. So today we are doing the distribution of the direct stiffness approach programming assignment, and we are also showing you some examples. So first group has been formed, Karan, Prashant and Major Mehra. Karan is the coordinator. So I am just sharing my screen and showing you the assignment. So just hold on. I'm just opening the PDF. Yeah, so I'm just opening the PDF and I'll be just sharing my screen. And in between, if for example I just disappear, you just wait, I'll come back in 5 minutes, but hopefully this will not happen. I won't have the crashing of the computer because I'm not sharing my camera. The moment I share the camera, there happens some problem. So I have shared my screen. Are you able to see the PDF document? Are you able to see?
Yes, sir.
All right. So this is now the programming assignment for your group. So your group is A. Okay. So this is also available in our website, course website. If you go web.iitd.ac.in // cvs756.html. in that, if you see useful links, so under useful links you will see this file. Okay, so these three members, you have this problem. So let me just read out. Basically you have to make a small computer program in any of the platform you choose. Say you can choose Fortran, or you can choose C++ or MATLAB. MATLAB is the easiest. And basically it's a 3D single story single bay frame, regular frame, orthogonal frame with a rigid slab. Okay, so rigid slab is there, and what you have to do, these are listed in steps number 1 to 4. First of all, user has to provide the bay length and the story height. Then the user has to provide horizontal loads. So basically the user can provide up to 2 positions where the horizontal load is to be applied in just x direction. Then the user has to give input the sectional properties, Young's modulus of columns and the beams. So all columns are assumed to be same, identical. All beams are assumed to be identical. And the bottom supports are assumed to be completely fixed. Alright. So basically the program is a specific program, is for a very small structure, just single bay, single story. So basically the program should follow the method of condensation, and you have to solve. Of course, it's optional. You can use the inbuilt algorithm in MATLAB, or if you are using any other platform, you need not program the inverse of KJJ. So KJJ inverse you can write directly from the code. But if you want to make a program for that, that is also optional. You are most welcome for that. And once you have made the program, then you test your program. How to test? Make a small structure, apply loads, and after applying the loads, you get all the nodal displacements, member end forces and the reactions, and then the test of the program is that it should satisfy equilibrium conditions. The loads you are applying and the reactions, they should balance each other, both in terms of the forces as well as the moments. Alright, so this is what you have to do. And then this is the third part also. This is optional, that you can generate the condensed stiffness matrix, and then you can also find out the first 2 or 3 natural frequencies of the structure. This is optional. And then the submission, the deadline is 15 December, and after that we will have a presentation. Okay, so this is the assignment for group A. Alright, so if you have any doubt from this group, you just let me know. Karan Fayaz, Prashant and Major Mera, you have any doubt, you let me know.
Okay, sir.
You have any doubt?
We will go through. We will.
Sir, we'll go through it once and then sir will then ask.
No, someone had raised the hand to ask for doubt. I think Karan, you had raised the hand that you had some doubt.
No, sir. It was already raised. Sorry, sir.
Okay, fine. So next group can come out. Which is the next group? So after I distribute, I'll show you a demo also. Any other group? Manish Gopal Agarwal, right?
Yes, sir.
Manish, who
Yes, sir.
are your other members? Your group number is B. Okay, Manish, can you be the coordinator?
Okay, sir. We have two others, that is Manish Kumar Meena and Ankish Chaudhary, sir.
Manish Kumar Meena and Ankish Chaudhary. So both
Yes,
of
sir.
you, Ankish and Manish Kumar Meena, you are here. All right, you are here. Fine. So your is number B. So I'm just opening number B. Member A and B are similar, but there are some differences also. So in the case of B, the only thing is that I have given a irregular structure. If you see now, are you able to see the PDF document? Hope you are able to see the PDF document for B, and the plan of the structure is shown here. The dimensions A, B and C are given. Alright. So basically you have to do this. It's similar to the A, only thing is that here the structure is irregular. So basically you have to get inputs from the user in terms of A, B and C, and based on these inputs you have to do your programming assignment. Okay, rest all things they are same.
Okay, sir.
Okay, all right. So now we go to next. Who comes now forward for the next C? Just raise your hand, and all those who have already got, you just okay. We have Sahil Garg, Hardik and Shubha Jyoti Jena. You want to form one group?
No, sir.
Okay, Sahil, who is with you?
Sir, one is Asif Ali Khan.
Asif, Sahil and one more?
Yes.
Or you want to have only two?
No, there is Mac also.
Who is next? Mayank? Alright,
Yes, sir.
Mayank,
Yes, sir. Yes, sir.
Sahil and Asif. So Sahil, can you be the coordinator? Or
No, sir. Asif.
Asif,
will
you
be,
can be coordinator?
Yes, sir.
Alright. So let me show you your assignment. I am opening now C. So this assignment is available in the form of PDF version in the website, course website. You all know the course website. Yeah, so this is number C. So now the difference is that this is a 3D two-story single bay space frame, but no slab, without any slab. Alright. It's a very regular structure, and it's the only difference is that it's two-story and no slab. Alright, lateral loads are in the x direction. You have to get the inputs from the user, and the other difference is that all the bottom supports are assumed to be pinned. Okay, so all the bottom supports, they are assumed to be pinned. So you have to apply the correction which we have learned how to take care of the pin supports. So that's what you have to do in this particular case. Rest all the problems statement is more or less same. So you have to test your program also, and the check is that your program, your output should satisfy the equilibrium check. And you can also run your problem in some standard platform like STAD student version. You can download and you can run this small structure where you can run very easily. Okay, that is C. Okay, next group, please raise your hand.
MATLAB also.
Yes, you can do on
Can you
MATLAB
do this
also.
Okay, sir.
So the platform is up to you. You can do in MATLAB, you can do in C++, any medium you can do. So just raise your hand. Anyone else? Okay, next D. Who wants to come to next group? Number D. Raise your hand. It's Shubha Jyoti Jaina and Hardik Parmar, right?
No, sir. Different group. Myself, Pawan Kumar and Dharam Singh.
You mean Shubha Jyoti Jaina, Pawan Singh
Kumar.
and Dharam Singh, huh?
Yes, sir.
Shubha Jyoti, Dharam Singh, and who is the third member?
Pawan Kumar.
Pawan Kumar. So who wants to be the coordinator among you? Who wants to be the coordinator?
I guess. It will be okay if I am the coordinator. If
Just
that
tell your
would
name
suit
also,
them.
because I am not able to see your video. I am seeing a array.
Sir, Subha
and
Jyoti.
Shubha Jyoti Jaina, okay. Alright, Shubha Jyoti Jaina, you are the coordinator. And let me show your program, your assignment. So your assignment is number D. So this is also a 3D story. 3D 2-story single bay. Okay, it is a 3D and it is 2-story. But the only thing is that its shape is not regular and there is no slab. So shape is like this. The plan shape will be like this. A, B and C, these dimensions you have to get from the user. Based on these dimensions, the program can work out all the coordinates and then form the structure and get inputs from the user, form the stiffness matrix and apply loads and then solve. Okay. So this case, there is no slab, without slab. Alright.
Yes, sir.
Okay. Next, who is the next group? Next group can raise your hand. Okay, Alina. Alina, who is with you?
Sir, Hardik and Amrendra Kumar Jha.
Okay, Hardik and Amrendra. So you can be the coordinator. Can you be the coordinator, Alina?
Sir, Hardik is the coordinator. Sir.
Okay, Hardik wants to be the coordinator. Fine. So your assignment is number E. So I am just opening that. All the assignments, they have some differences, small differences. So number E I have opened. Your is 3D 2-story single bay orthogonal space frame with no slab. Okay, it's 3D, it's orthogonal and there are lateral loads in the x direction only, and all the bottom supports, they are fixed. Okay, so assume your bottom support conditions, they are all fixed. Alright, and rest all the conditions, they are similar. So only difference as compared to the other 3D structures is that your bottom supports, they are all fixed. Alright. Okay, next we have 2 more groups now. So next, raise your hand. We have just 2 more groups, F and G. Who wants to come? Okay, Namrata Pandey, you want to do solo, alone?
Yes, sir. Yes, sir.
Okay, Namrata, you are given assignment number 6. So I am just opening that. Sorry, assignment number F. I am just opening that. Yeah. So this is a 3D single story, single bay space frame with rigid slab.
Okay, sir.
And here the lateral loads are acting. And all the bottom supports, they are assumed to be hinge. Alright, so this is the difference. And the user has to provide information in terms of A, B and C. Alright?
Okay, sir.
Okay, fine. And then we have the last group. Last group, please raise your hand. Last group who is left now Varun Kumar, right? Varun, who are
Yes,
with
sir.
you?
Sir, can I do it solo?
Solo. But who are left
Yes, sir.
now? Who are left now here?
Sir,
Let me just.
myself.
Only you.
Sir, can we include him in our group?
I'm also, sir. I haven't formed any group, sir. Actually, what happened, sir? I talked to one guy, then he left day before. Yeah, yesterday he said that I will be dropping the course, so now I am also.
Excuse me, sir.
Just a minute. It's difficult to make out who is talking. So Varun Kumar, let me first give the mic to Varun Kumar.
Sir,
So Varun
myself.
Kumar, you want to take someone?
Excuse me, sir.
I will give you a chance, Namrata. Just hold on. Varun Kumar, just you raise your hand if you want to talk something. Raise your hand because it creates confusion. Because I am also not in camera and you are also not in camera. Varun Kumar, you want to do it alone? But you have Rahul Dabar. Rahul?
Yes, sir.
Rahul Dabar, you have not joined any group. Why don't you join Varun Kumar?
No, sir.
You don't want to join any group?
Sir, I will join.
So Varun and Rahul, I can count you together.
Yes, sir. Yes, sir.
Okay, Varun and Rahul. So who wants to be the coordinator?
Varun, sir.
Varun is the coordinator. Okay, so you are given the assignment number G. So G is like this. So it is a 3D, 3-story. It's a 3-story single bay orthogonal frame. Alright? And no slab. The only difference is that it's 3-story. So 3 stories means that there are 9 joints, that is 27. KJJ will be 27 by 27. Okay? Rest all are things, rest all conditions are same. And assume all bottom supports they are fixed. Alright? So we have done the distribution, and now who was raising hand? Namrata, you wanted to speak something?
Yes, sir.
Yes.
Actually-
Tell me, you are solo. You can do it.
Sir, actually, I have asked few people, and they have already made the group. So I was having the idea that everyone have made their group, and they were 3 people in one group, 3 persons in one group.
Okay.
So I asked you for solo.
All right.
Sir, if the last group has no problem, then we can be 3 persons in a group because they
We
are
are having, sir, 2.
and-
We can have. We
So
can
okay,
have.
Varun, Rahul, and Namrata, you can form one group.
Yes, sir.
Okay.
Okay, so you will be
Yes.
you will be doing assignment number F. Okay.
Okay,
So who
sir.
wants to be the coordinator, Varun or Namrata?
Sir, if they don't have any problem, then I can be the coordinator. Or if they will say any one of them wants, then I don't have any problem with them.
Okay, Varun, so Namrata can be the
I don't
coordinator,
have-
or you want to be the coordinator?
Yes, sir. Namrata can.
Okay, Namrata, you can be coordinator. So
Namrata can
you make sure now you will be doing assignment number F, not G. Okay. So I think we have
Okay,
covered
sir.
everyone. There is no one left now. I think if anyone is left, everyone has covered. Everyone has joined some group. Okay. Except that we have Pragati Sharma has left. Deepak Berba has left. Nikhil Khullar. Nikhil Khullar is absent. Prashant Yadav has left, and Kritika Leela, are you there? I think today Kritika Leela is also not around, because if now she joins, she will be given a solo project. Okay, we have one backup project left for those who are not there in case they come. Okay, so let me now show you some example. I will just share my screen. I am just unsharing this document, and then I'll screen share again, and I'll try to run one MATLAB program of one of your former senior students. Okay, just hold on. So let me now run MATLAB on my screen. You all can install MATLAB from the Computer Service Center website. Now it does not even need VPN access to run. You can run very easily from outside. So this assignment, what you have to do, you have to make a plan. Plan means stepwise write down what are the steps required and what are the different functions within your whole program, and you divide the work among yourselves. And you have to regularly meet. Okay, so now I am sharing my screen. I'm just sharing my screen. Is the MATLAB code visible to you all?
Yes, sir.
Okay, so this is a MATLAB
Yes,
code
sir.
written by one of the former students, and he had made a interactive program. So I'm just running it. So let's say I press the button run. There will be a small lag. So okay, now it has opened a window and it's asking the number of spans. I just enter 1, the number of bays, the number of stories, and then it's asking the span length. Let's say I enter 5 meters, the bay length 5 meters. Basically span length and bay length, they are basically the dimensions along the x and y axis, horizontal axis. And then it's asking the story height also. So I enter the story height also 5 meters. I say okay. Next, it has shown me a figure cross section of the beam, and it is showing the local as well as the global directions. And now it's asking me to enter the different sectional properties of the member in terms of the local axis. So it's now showing the beam, and it's asking the sectional properties like area. So I'm just entering some values, arbitrary values I'm entering. To save time, I'm just entering 1, and then it's asking the modulus of elasticity also. The units are also specified. I'm just entering some value to E9. Modulus of rigidity is also asking. I'm just entering 1 E9. Torsional constant. Now if you enter the torsional constant, the beams will get some torsion also in case of unsymmetrical loading, but you can choose to enter this as 0 also. So our code IS456 gives us both the options. So I am here entering some values. 0.1 I am entering, and now it's asking for the column. So the cross section of the column is also shown, and I enter the values here. I am entering the values.
It is saying that it is for column.
Yes, it's for the column.
How do we know that it is for the column?
You see the picture. It shows vertical member.
Okay.
So I have entered here the values and then say OK. And now it has drawn a sketch of the structure. Do you see a figure? Figure has come. I just enlarge this figure. So this figure is in MATLAB, and you can rotate and flip this figure like this. You can turn around. Do you see this flexibility? So this flexibility is there in the MATLAB. If you make a 3D figure, you can always do these kind of manipulations and see how it looks like from different angles. Alright. So this is the sketch, and then it asks the number of loads, how many loads we want to apply. Let's say we say 2 loads, and now our 1 load, let's say I just apply 1 load, and it asks me what is the magnitude of the load. Let's say I enter here 100 kilonewton, and which node it is asking for the node also. So let's say here the nodes are also numbered. So I say I apply in node number 2. So I enter here node number 2, and then it asks for the direction. X-axis we have to enter 1, y-axis we have to enter 2. So I keep 1. So that's it. And then it asks for the depth of the slab. Now this it's asking because the program is doing some calculations for dynamic analysis also, natural frequency. So for that purpose it wants to find out the mass. So that's why it's asking for the depth. So let's say I enter the depth as 250 mm, 0.25, and say OK. Yeah, the program has run, it has completed, and it has opened the output. I think you must have seen here output.txt. So first of all, if you go through this output, first of all it will repeat the inputs which are given by the user. So if you go down this output, and it gives us the floor displacements, ux, uy, and the theta. So floor displacements are here, and then the nodal displacements of the 4 points at the first floor level, they are also given, and then the reactions are also given here. We can see reactions, and then all the member and forces, 6 member and forces at each end. So there are 12 member and forces for each member, so they are also given in terms of the local coordinate system. So this is how this program runs. So this was just an example. Now I show you another example, and that source code I'll share with you. That is in C++, and in fact C++ you can install in your Windows 7, 8, and even Windows 10 also you can install. It's a very small code, very quickly it installs, and I just show you. I'm just opening it in my computer. So basically you have to make input file like this for that purpose. Let's say I hope you are able to see my screen.
Yes, sir.
Alright, so input files, they are made like this. Like this is a input file I am opening. So in this input file you have to specify make a text file like this, like these are the member properties, like here area is specified, IY, IZ, J, all these values are specified, and then floor elevations are given, and then the joint coordinates are given, and then the floors are specified, and then here the members are specified, that member 1 is from joint number 19 to 15, and the member type is 1, and the local y axis is towards the global y. So this way these things are specified in a text file, and then the joint loads are specified, and then this is an input and it produces the output. So I'll just show you how it runs. So I'm just opening the console of Turbo C. So I'm opening Turbo C. I hope this is visible. Now Turbo C dialog box is opening in my computer. I hope it should be visible. So I have the file, it's already open. So all I do is I just compile it. I press the button compile, build all. So it has compiled, 0 error, and then I can just run it. So I press the run button, run. So now it's asking me the name of the input file. So I just input here the name djp_ex.txt. This is the input file which I had shown you. Then it asked me which name I want to give to the output file. Let's say I give here the forces.txt, and then it asks me the output file for the displacement. So I give here displacements.txt, and then it has completed the analysis. So let's go to the output. I'm just closing this. I'm just pressing Windows D so that I go back to the desktop. Windows D. Yeah, I am back. This works in the DOS version. Okay, now I just open the folder and see where are the outputs. So I go here in the drive C, and here there is a Turbo C. If you install this, it installs in just a couple of seconds. So you'll see a Turbo C folder. So TC will be there, then there will be bin folder. So basically you have to input your input file, like here this was my input file, this should be there in this folder, and the output will also be created here, and the programs SAB 3D should also be there here. So let me just open the output. What were the name? Forces, F. So forces and the displacements. Yeah, this is the forces file. So all the member and forces you can see here. This is for member number 1, the forces in the X, Y and Z direction, and then the moments also. Okay. and you can see here this is a column member, so axial forces are there, and then when we go to a beam member, there won't be any axial forces. For example, now member number 5 is a beam member, so you see there is no axial force, that's why we are getting something to the power of minus 30. So member number 5 is a beam member, no axial forces. And let's open the displacement file. Displace, yeah, it has made this as the file displacement. Yeah, this is the displacement file. So first it's giving the floor level rotations, because this is a building like this, single story, and then there are the joint displacements. So I'll just show you a view of this building also. These are all the joint displacements and the floor displacements. I'll just show you a view of this building. The view of this building. Yeah, this is the typical view of this particular building which we had analyzed. Okay, so I think we had opened the wrong wrong output file. Let me open again. Let me just open again. I had by mistake opened the wrong output file. I'm just going again. This is means forces file I had opened correctly. The displacement file, there was some problem, I think. I just go again to the computer C, and then we have the turbo C4 and TC, and then the bin, and then the displacement. It should be today's date. Yeah,
So
this,
arrange कर दीजिए ना डेट के साथ. Okay.
yeah, this is the correct file. This is the correct file. There are three levels. There are three levels, 1, 2 and 3. So all three levels there are these displacements, floor level displacements are there, and then there are these are the joints. So it's a 3-story building. So this is correct displacements. The only thing is that we had specified the name as displacement, but the program has truncated some portion, so that's why this confusion was there. So it's correct file. So all the three levels we have seen. This is a 3-story building, and we have the 3 levels. All 3 levels we have the displacements. All right. So this programming resource I'll attach in the Moodle, and I'll also attach in the MS Team, so you can download this example code and you can run it yourself. All right. It also gives you the how we specify the input file. All right. So this is what we have to discuss about today. So I think now I am back. I have now shared the screen. So now you can ask any questions. If you have any questions, any doubts, you can let me know. The programming assignments A, B, C, D, E, F you can get from the course website. Link is there. And the programming resources, I have made a zip file, and that zip file I'll just share online. I'll upload in the MS Team channel itself, and I will also upload in the Moodle. Both ways you can just download that, install it in your computer, and you can run. So you have any question, just raise your hand. Hello, are you all around? Yeah, Namrata, please ask your question.
So for the presentation part, we have to present through the software or the language only, or we have to make a PPT for that and then present both the things.
Yeah, you have to make a PPT. All right.
Okay, sir.
And along with the PPT, just arrange a small demo, just like I have shown you the demo in MATLAB. So you also can share your screen and give a small demo of your program on a sample structure. Okay.
Okay, okay, sir.
Alright, so that's how you have to go.
Okay, sir.
Okay, any other doubt? If you have any other doubt, please let me know, and I'll just, after this session, I'll just upload the zip file. So if you download that zip file and unzip all the files, you will get a lot of resources as an example, and you will get a sample code also for that kind of building which has stiff floor action. So any other doubt, just raise your hand.
Sir, will be there any tutorial on MATLAB session?
MATLAB actually, MATLAB, let me tell you, the Computer Service Center, they keep organizing these kind of sessions. Last time they had organized a couple of months ago also. So you be in touch with the Computer Service Center, send them the query. Otherwise, MATLAB is very easy to learn. There is a support. MATLAB is giving special support to IIT Delhi. So if you, for example, contact them with IIT's ID, they will immediately attend to your problems. And last time I remember, Computer Service Center, they had organized a workshop on MATLAB, online workshop. So they keep organizing. So just you be in touch with the Computer Service Center. Dr. Ramlal is there, who organizes these workshops. All right. Otherwise, you can learn. To learn the MATLAB, let me tell you how to learn. I am just opening my website, but thing is that sometimes, you know, in this computer the Chrome crashes, so I am opening in Mozilla. So I am just opening my website and I am just sharing the screen. So just hold on. I tell you a simple tutorial how to learn MATLAB by yourself. Okay, now are you able to see my screen? I am now opening my website.
Yes,
I am just typing my own website. So this is my website. So I am just taking you to the link for another course, UG course. So a couple of years ago, we used to have a self-learning UG course, CEL, I mean a UG course with a self-learning module for MATLAB. So CEL 331 I am opening, so I hope you are able to see it. So this is an undergraduate course, and here you will see a MATLAB learning exercise. Do you see a MATLAB learning exercise link? So it's a PDF file. Yeah, so this is a MATLAB learning exercise. So if you follow these steps from number 1 to number 16 and number 20, if you follow these steps from step number 1 to step number 20 interactively and in trial and error manner, you will learn MATLAB. Okay, so just keep following these steps. So if you are able to do steps number 10, you will have certain level of understanding of use of MATLAB, and if you are able to complete all 20 steps, then you will learn, you will have a certain level of proficiency in MATLAB. Okay, so this exercise, please note that you have to go to the website of another course, CEL 331, an undergraduate course. So there this MATLAB learning exercise is there. All right. So I am unsharing this screen. So if you have any other doubt, I am unsharing the screen. If you have any other doubt, you please let me know. And tomorrow we have special class by Dr. S.K. Dhawan at 12 o'clock. He will give a special, it's an extracurricular talk on high-rise buildings, on practical aspects of high-rise buildings and some analytical aspects also. So hope you can start now doing your assignment. If you have any other doubt, raise your hand. So today I think Kritika is absent, and then what happened to Nikhil Khullar? Nikhil Khullar is also not coming. Nikhil Khullar. Alright, so I think we close the session now. I hope you don't have any doubt. So Bishu, okay, Alina, you are raising hand. You have some question?
Yes, sir. Actually, when I tried solving the previous year papers, I'm having so many doubts.
Okay.
So, shall I send you via mail or in WhatsApp?
Okay, doubts, what we will do, we can have one session especially for doubts. Will that be fine?
Okay.
But
Yes,
when
sir.
do we have that session? Because your exam is on Sunday, right?
Yes, sir.
Coming Sunday you have exam, so can we have a special session on doubts, maybe beyond your regular timings?
Yeah, sure, sir.
You can discuss among yourselves and tell me a suitable time when you all are free, and we can have a 1 hour session on doubts.
Okay, sir.
Okay, will that be fine? So just discuss
Yes,
among
sir.
yourselves and tell me some particular time in the WhatsApp group, and we can finalize some time for that. Maybe we can have that on Friday or Saturday we can have. Maybe Friday will be better. Thursday you have, that is tomorrow, you have a lecture by Dr. Dhawan, or evening time, any evening time, say 6 o'clock, 7 o'clock, 8 o'clock, that is also fine with me. Okay, the
sir.
advantage will be
Discuss and
that
let you know, sir.
advantage will be that if you ask questions, so that will solve the doubts of many others also. Okay, so it's better that we discuss these doubts in a classroom fashion.
Okay, sir.
Alright, so we are closing the session. Thank you very much.